So we're going to continue today with section 9.3. Last week we did 9.1, which was standard form. Today we're doing 9.3, which is vertex form. Now, vertex form compared to standard form, the word form just means the way it's organized. So in a standard form, it's organized like this: ax squared plus bx plus c. Vertex form, it's organized like this: a parentheses x minus h, close parentheses, to the power of 2 plus k. And this is all on the wall. And we'll continue with this in a bit. Right now, let's jump to our notes. On the notes, it has a class opener right here. I'm going to pause it. I would like you guys to do it just so you could warm up and remember how to find the vertex and how to use the pattern and all that stuff, right? I'm going to pause it, then I'll explain it in a bit. Go for it. Ready or not, I'm about to explain it. Here we go. Step one is to do what? Find the vertex. If you forgot, it's on the wall right there, vertex. And this is what I want you to copy down, exactly what you see right here. I always copy down the word vertex. I always write down the coordinate right there. I even write down the formula, and I replace the formula with parentheses. So that's what you should do. You should write that down on your paper. Okay, now once you write it all out like this, you'll be able to clearly see your b value and your a value from the standard form quadratic trinomial. So the b value is -2, the a value is -1. So -2 goes inside of the first parenthesis up on top. -1 goes on the bottom. Up on top, a minus minus 2 becomes a +2. And on the bottom, 2 times -1 is a -2. So what we really have is a -1 as our x value. It says x equals -1. So the vertex x value is -1. Now we still need the y value. How do you do that? Anybody? You just substitute, right? We're going to rewrite the whole function, but instead of x's, we're going to put parentheses. That way we could plug in the -1 right into those x's. Here it is. I just rewrote it with parentheses instead of the x's. So now I could take that -1 and put it right in there. Super easy, a -1 right there and a -1 right there. And then you could type it into the calculator, get an answer, or you could do it by hand like this. -1 to the second power, that's +1. But don't forget about this negative sign. Just bring that negative sign down, that's a -1. Then you could multiply -2 times -1, that's +2. Then you could also bring down this -1 right here next to the 2, -1. And you could go from left to right. -1 plus 2 is 1. 1 take away 1 is 0. So you end up with a y value equaling 0. Now that is a vertex y value. That's the most important point. Let's graph that point. -1 on the x, 0 on the y. That's right here. And of course, you could draw an axis of symmetry right through it. And you need more points to be able to graph this parabola. You could go for an input-output table, and you could just randomly start plugging in numbers. Give me a number, any number you want. 4. If I plug in 4, it's not going to work out that great. Let me show you why. Because when I plug in 4, 4 squared is 16. With the negative in front, that's a -16. 2 times 4 is 8. -16, take away 8. That's -24, -1 is 25. So when you plug in a 4, you get out a -25. That's the location 4 on the x, -25 way off the graph, right? So an XY table, even though it works to give you points, it's not the best option. The best option is to use a pattern from your vertex. Because the a value is -1, you could use the pattern 1, 1, 2, 4, 3, 9. But just remember that because it's negative, it's opening down. So instead of 1 over 1 up, you're going to go 1 over 1 down and put a dot right there. Then back to the vertex and go 2 over 1, 2, 3, 4 down, put a dot right there. And if you try to go 3 over 9 down, you're off the graph, so we're not going to do that point. Okay. You could map them over to the other side, or you should, right there and right there. How did I do that? It's 1 unit away from the axis of symmetry, go 1 unit this way. This one's 1, 2 units away, so go 1, 2 units this way. And you have your parabola. There it is. That was what we did last week. And also, in addition to graphing, I asked a bunch of questions. Like one question was just, what is the vertex of this thing? And we just found the vertex. Another question is, what is the axis of symmetry? And in case you forgot, you could always look at the board and read axis of symmetry right there. It says x equals the x value of your vertex. So the x value of our vertex here is -1. So you're going to write down x equals -1. Okay. I could also ask you for the domain. Everybody should remember that the domain of any parabola is x equals all real numbers. And if you don't remember, it's on the wall. Okay, so the domain x equals all real numbers. The range is pretty easy if you already know your vertex. You see the range, if the parabola is opening up, if the a value is positive, it's going to be y is greater than or equal to the y value of your vertex. If the parabola is opening down, if it's a negative a value, it's going to be y is less than or equal to the y value of your vertex. So right here, it's opening down. We already know that the a value is negative, so that's going to be y is less than or equal to. So for the range, we're going to write y is less than or equal to the y value of our vertex, which in this case is 0. Okay. What else could I ask? I guess I could ask for the y-intercept. These are all things that I asked last week on the quiz. Hopefully we remember this stuff. We still need to know this stuff this week. How do you find the y-intercept? Anybody? Yes, set x equal to 0 and solve. All right, now that's really easy to do on a standard form because when you put zeros right here where the x's are, everything cancels out except for the c value. So in this case, it's 0, negative 1, and you could clearly see that that's where it crosses 0, negative 1. Anyways, today we're going to learn a new form, which is a vertex form. Okay, so let's begin by reading it. A standard form, a, b, and c are just numbers. Over here on a vertex form, a, h, and k are just numbers. Okay, the a value is on standard form, and the a value is also on vertex form. The a value is the same thing as what it used to be. The number out in the front, that's the a value. The number out in front of the parentheses is the a value. Okay, what did the a value tell us? It tells us if it opens up or down. If it's positive, it opens up. If it's negative, it opens down. Not only that, it tells us if it's wide or narrow. The closer it is to 0, the wider it gets. The further away it is from 0, the narrower it gets, right? Same thing here. So the a value is exactly the same. Now, last week, to find the vertex, we had to use the formula just to get the x value of the vertex. Then once we had that x value, we had to plug it in to find the y. Vertex form is beautiful. Why? Because h and k are your vertex. Let me repeat that. You're going to be able to look at it and identify your vertex, hk. H is your x value of your vertex, k is the y value of your vertex. So it's super easy. The only thing that's kind of confusing, or that you should remember at least, is when you identify h, think opposite of what you see. So if you see a -7 right here, the h value is actually a +7. If you have a +1 right here, the h value is actually a -1. It's opposite of what you see. You get that? You think opposite of what you see on h. Okay, let's see if you get that. Down here, we have some quadratic equations, and these are in vertex form. On the word wall, look, this is a new paper I just added today, vertex form. The a value is out in the front. Inside the parentheses, you have x minus h, and with a square on the outside, and then plus k at the very end. You got to get really comfortable with this form. You should memorize the form, right? Whenever you identify h and k, that will be your vertex, but think opposite of what you see for h and take k for what it is. That's what it says on the board. That's what we're going to do here. So, Jose, what is the h value of number 1 right here? What's the h value? You got to, okay, h is always going to be inside parentheses. It's always going to be inside parentheses being subtracted from x. Okay, so what is our h value right there? 7. That's right. So we could all look at this thing and identify the vertex. The x value is 7 because that's the opposite of what we see here. See, so technically this is our h, but you got to think opposite. And our k value is what? What's the number that's being added or subtracted at the very end? There is no number that's being added or subtracted at the very end. And it's not a 1, it's a 0. So 7, 0, right? Okay, so I guess what we got to get familiar with here is vertex form. The h is going to be inside parentheses being subtracted from x, always. It can't be outside. It has to be inside parentheses being subtracted from x, and that's going to be the x value of your vertex. The k value is a number that's being added or subtracted at the very end, And that's what you take the way it is. So if you see a -3 out here, the y value of your vertex is -3. If you see a +8, the y value of your vertex is a +8. But the x value of your vertex is opposite of whatever you see here. So if you see a -2 right here, the x value of your vertex is +2. If you see a +9 right here, the x value of your vertex is a -9. Think opposite on h and take k for what it is. Yay? All right. So right here, think opposite on h, that's +7. Take k for what it is. There was no number, so we just put a 0. Okay. How about right here? What is the vertex right here? Everybody write down vertex. Write down the coordinate and tell me what that coordinate is. For number 2, what's a vertex? What's the hk value? The h and k values. Okay, but think opposite on h. Think opposite on h and take k for what it is. Jorge. Your vertex is the opposite of 3, which is -3, and you take k for what it is, which is -8. That's your vertex, -3, -8. You guys got that? Let's skip to number 4 right here. Jorge, what is the vertex here? What's the coordinate of the most important point, the vertex? You think opposite on h, take k for what it is. What's the vertex? +4, comma, -1. It's pretty simple. Think opposite on h, take k for what it is. So you guys probably think, dang, this is easy. It is. But what about this guy right here? This one doesn't look like it's in vertex form because vertex form has parentheses with the square on the outside, right? So what you got to do is make it look like it, all right? First of all, let's start by putting parentheses. Let's put parentheses right around the x. Don't go all the way out here. That's incorrect, okay? Don't go all the way out there. Just around the x. That way you could clearly see that your a value is +2/3. Your h value is a number that's being subtracted from x inside the parentheses. What's your h value going to be? If there is no number, 0. And your k value is a number that's outside all by itself. So the vertex is 0, 5, right? And you can go to the rest from that. So here, let me just rewrite it so it'll look a little bit nicer. The a value is 2/3. You have parentheses x minus h squared, where h is 0 because it never had a number being subtracted from x inside the parentheses. And then the plus k out here by itself. So you put plus that k value of 5. Now you could clearly see that your vertex is 0, 5. Now, if you understand that, guys, it's going to be ridiculously easy to graph. Check it out. Let's go over here. And let me begin by I'll do this one just real quick. Before, it would take me like 7 minutes to explain how to graph a parabola. But if it's in vertex form, it's this simple. What is a vertex? Think opposite on h, that's +1. Take k for what it is, +3. Everybody plot the point, 1, 3. 1 on the x, 3 on the y. There it is. What's the a value, the number out in front of the parenthesis? It's a -1, right? That means I could use a pattern 1, 1, 2, 4, 3, 9, but just remember that it's going down instead of up. So check this out. 1 over, 1 down, put a dot right there. Go back to the vertex. 2 over, 4 down, that's put right there, put a dot. Go back to the vertex and go 3 over, 1, 2, 3, 9 down, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm 1 unit off the graph. You don't have to put it. I'm going to put it just because it's only 1 unit off. It's right there. Más o menos. We do have an axis of symmetry going right through that vertex. All you got to do is map over this point 1 unit away, go 1 unit this way. I want to put it as a blue dot. And then another one over here 2 units away, go 2 units this way, right there, and put it as a blue dot. And then this one that's off the graph, it's 1, 2, 3 units away, 1, 2, 3 units away, put a dot out here off the graph. Now, again, you don't have to do these that are off the graph, but if you want to, that's fine. There's your parabola. You can just put it pointing towards those dots that are off the graph. And voila, we're done. Cool. We didn't do any math. We didn't use a formula. We didn't really, pretty easy. It's super easy. It's way easier than what we were doing before, okay? Now, I could still ask you anything from before. Like I could ask you, what is the axis of symmetry? The equation x equals the x value of your vertex, x equals 1. I could ask you for the domain, which is all real numbers. I could ask you for the range, which is y is less than or equal to the y value of 3, okay? I could ask you anything that I did before. The only thing that is not, that's kind of confusing is back when we found the y-intercept on a standard form, how would we find the y-intercept? You would set x equal to 0 and solve, and that's really easy when it's in standard form, because if you put your x's to be 0, what's left? The number at the end, right? But if I asked you, what is the y-intercept of this guy? The y-intercept is not that last number anymore. I mean, you could clearly see that it does not cross at 3. It actually crosses at 2. So how the heck do we do that? How do you find the y-intercept here? You do it the same exact way. It says to find the y-intercept, set x equal to 0 and solve for y. So that's exactly what we need to do. We're going to set x equal to 0. There's a 0 right here instead of x. Now imagine that. What is 0 take away 1? That's -1. What is -1 squared? -1 times -1 is +1. But with the negative in front, that'll take you back to a -1. And what is -1 plus 3? It's 2. That's why the y-intercept is setting x equal to 0 and solving and getting out a 2. That's why it crosses right here at 2 as opposed to it crossing at 3 on a standard form, okay? So there are some benefits to having it in standard form. There are some benefits having it in vertex form. Vertex form is way better. Vertex form, it's easy to find the vertex. It's easy to find the axis of symmetry because it's just x equals the h value, and you got to think opposite on h. It's easy to find the range. The range will be y is less than or equal to, because it's a negative a value, it's opening down, the y value of your vertex, which will be the k value of your vertex form, which would be y is less than or equal to 3. So vertex form is great, but it is easier to find the y-intercept of a standard form as opposed to a vertex form. Because standard form, when you find the y-intercept, when you set x equal to 0, when you put these zeros in for x's, everything cancels out, and that's your y-intercept. But for vertex form, you actually have to plug in a 0 and then do the math and then square it, then multiply by a, and then add k. Then you'll find your y-intercept for vertex form. Anyway, what is my vertex for this guy? Oh, yep, 0, comma, -5. Everybody plot the point, 0, -5. 0 on the x, -5 on the y. It's down here, right on the edge. Right through that dot, there's an axis of symmetry. I need more points. You could go for an XY table, or you could use a pattern 1, 1, 2, 4, 3, 9. But you especially could use this pattern because the a value is 1, right? There's a value of 1 out here in the front. The h was 0 because there's no number being subtracted from x. The k is -5. All right, so from the vertex, go 1 over 1 up, put a dot there. Back to the vertex 2 over 4 up, put a dot there. Back to the vertex 3 over 9 up, put a dot up here. Map those dots to the other side, right there, right here, and up there. And voila, you have your parabola. I can't believe we're graphing it that quickly. What's my vertex on this guy? -3, -5. Go ahead and plot that point. -3 on the x, -1, 2, 3, 4, 5. You actually have to count this is not a 5 by 5 graph. Draw your axis of symmetry right through it. Is this opening up or down? The a value is what? +1, so it's opening up, right? So if it's opening up and the a value is 1, we could use the pattern 1, 1, 2, 4, 3, 9. So just go 1 over 1 up, put a dot right there. Back to the vertex, 2 over 4 up, 1, 2, 3, 4, put a dot right there. Back to the vertex, 3 over 9 up, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, put a dot right there. Map those dots to the other side of the axis of symmetry. What do I mean by that? It's 1 unit, 2 units, 3 units away, 1, 2, 3 units away. Put a dot right there. This one is 2 units away. What, 2 units? So go 2 units this way and put a dot right there. This one's 1 unit away. Go 1 unit this way, put a dot right there. And we have our parabola graphed perfectly without doing any math, really. What's a vertex for this guy? Yep, if you put parentheses around the x, then the h is 0 and the k is -1, right? Think opposite on h, which there's nothing to think about. The k value, take it for what it is, so 0, -1. Plot that point, 0 on the x, don't go left or right, stay at 0. Go to -1 on the y, put a dot right there. Is this opening up or down? What's my a value? -1, which means it's opening down. And we could use a pattern 1, 1, 2, 4, 3, 9, but just make sure you're going down. So if I do go 1 over 1 down instead of up, I'll be right there at that point. Back to the vertex, 2 over 4 down, I'll be right there on the edge. Back to the vertex, 3 over 9 down, I'm off the graph, I'm not going to plot it. Just map them over to the other side of the axis of symmetry right there, and voila, we are done. I hope we're seeing how amazing vertex form is, because you could graph this thing without doing any math. Seriously, last week, if I told you to graph one of these in standard form, it takes you a good 5 minutes to use a formula, to plug in your x value, find your y value. It takes a long time. Right here, we're graphing it in a matter of a minute, tops, right? What's my vertex here? -1, 0. That's right. Think opposite on h, and there is no k, so take k for what it is. So -1, 0, that would be right there at that location. We know there's an axis of symmetry going right through it. We know that we could use, well, first of all, does it open up or down? Down, because the a value is negative. Okay, so instead of going 1 over 1 up, 2 over 4 up, 3 over 9 up, we're going to be going 1 over 1 down, and put a dot right there. Back to the vertex, 2 over 4 down, right there. Back to the vertex. If I go 3 over 9 down, I'm off the graph, so I'm not going to use that last part of the pattern 3, 9. But I am going to map it over to the other side, right there and right there. Put some arrows on it, and you have your parabola. Pretty amazing, right? Now, keep in mind, I could ask you anything that I asked you before. I could ask you I could just give you this and not give you the graph and be like, what's a vertex? Oh, you got to type in the vertex -1, 0. I could ask you for the axis of symmetry. That'd be x equals the x value of your vertex, which in this case is h, which in this case is -1, the opposite of what you see there. I could also ask you for like the domain. The domain's x equals all real numbers. I could ask you for the range. Y is less than or equal to. How do I know it's less than or equal to? Because it's opening down. But even if I didn't see this, I know it's less than or equal to because the a value is negative, which means that it has to be opening down. Okay? And it's y equals less than or equal to the k value of the y value of your vertex, which happens to be the k value in this case, which happens to be 0. So I could ask you any of these things. The y-intercept is kind of tricky because we're so used to seeing the last number and saying that that's a y-intercept, but that's not the case here. Right here, the y-intercept is what? That location. What is that location? 0, -1. And again, if I gave you the original and I asked you to do it algebraically, you'd have to set x equal to 0. 0 plus 1 is 1. 1 squared is 1. With a minus sign in front would be a -1. So when you plug in a 0, you get out a -1. That is the y-intercept right there, 0, -1. Anyway, if you flip the paper over, you're going to see more notes that we're not going to do today. We're going to wait till Wednesday on that. But if you go to the other paper, the homework, where I want you to practice graphing in vertex form, you're going to see this page, and it's really easy to graph and answer all this information. You guys want to see the easy one or like the hardest one? Hardest. Everybody go to number 5. But look how easy it is. Even though this is the hardest one, what's my vertex? Negative 3, 4. Okay, let's go to negative 3, 1, 2, 3, 4, 1, 2, 3, 4. Everybody plot that point, negative 3, 4. And then now it's easy to state the axis of symmetry, the line that goes right through this. What is that line? X equals the x value of your vertex, negative 3. And each one of these things that I'm stating could be their own questions on the next quiz that we have. What pattern are we going to use? Well, we're going to have to modify the original pattern of 1, 1, 2, 4, 3, 9 because we have a new a value, and the new a value is negative half. This is probably the hardest part of this whole process. Instead of 1, 1, 2, 4, 3, 9, we need to multiply the outputs, the 1 by negative 1 half, the 4 by negative 1 half, and the 9 by negative 1 half. That will give us negative 1 half or a negative 0.5, only halfway down. And then the next one, 4 times negative half, that's negative 2. You could actually do that. And then the next one, negative 4.5 with the calculator. 9 times negative half is negative 4.5. That's negative 4.5 down. So the new modified pattern here is 1 over halfway down, back to the vertex, 2 over 2 down, back to the vertex, 3 over 4.5 down. Now on quizzes, the only part of this pattern that you'll be able to utilize is 2 over 2 down. So 2 over 2 down, that would give you a nice point right there. And you could map that over to the other side right there. But since it's not quizzes, since you're doing it on paper, you could actually go 1 over and only halfway down. Check it out, 1 over and only halfway down. So you could put a dot right there halfway. Let's do that. And you could map that halfway point to the other side of the axis of symmetry. 1 unit away, 1 unit away right there at that halfway point. I hope everybody's understanding. And you could also use the last part of the pattern, 3 over and negative 4.5 down. So from the vertex, 1, 2, 3 over, 4.5 down. 1, 2, 3, 4 down, and then half more. So you'd be right here at this halfway point. Go ahead and put a dot right there. Then, of course, you could map that dot to the other side of the axis of symmetry, which is 3 units away. So go 3 units this way and put a dot right there at that halfway point. And ladies and gentlemen, that is your perfect parabola right there. This was hard because we had to modify the pattern according to the new a value of negative half. Finding the vertex, thinking opposite on h, taking k for what it is, that was easy. Pattern, a little bit challenging, but not bad. We've done this before. And now for the rest, you could state what is the domain? X equals all real numbers. That's always true on any parabola. Doesn't matter if it opens up, down, if it's wide or narrow. The domain's always the same. X equals all real numbers. The range are your y values. And the range, if it opens down, it's going to be y is less than or equal to. And you know it opens down because the a value is negative. Or you could just see it opening down. So that would be y is less than or equal to the y value of your vertex, which is technically your k value. So y is less than or equal to 4. Now, the y-intercept, to find the y-intercept, you set x equal to 0 and solve. So if I did set x equal to 0, imagine that. 0 plus 3 is what? 3? What's 3 squared? What's 3 times 3? 9? What's 9 times negative half? That's negative 4.5. What's negative 4.5 plus 4? That'd be a negative 0.5. So negative 0.5. Did the work in my head. I hope you followed along. But what does that mean? That my y-intercept will be at 0 and then only halfway down. So that's why the y-intercept is right there. And sure enough, that parabola does cross perfectly through those halfway points. Now, for the x-intercept, we haven't really done this yet. And I don't want to be precise, but I just want to get a más o menos approximation. So you could say the x-intercept will be, that means approximately, it looks like it's at negative 6, but almost negative 6, not quite negative 6. So that's going to be like a negative 5.9. And it also looks like at almost 0, but a little bit on the negative side. So maybe negative 0.1. And we've just answered everything we could possibly answer about this parabola. And this is as hard as it gets, and it's actually not that difficult, especially when you're able to just see the vertex. Opposite on H, take K for what it is. There's your vertex. Modify your pattern if you need to. Everything else is exactly what we did last week, okay? So you guys should be able to do this easily. For the rest of the class, I want you to work on this. The solutions are posted on Google Classroom. You know what? You want to do another one? Pick one. Which one do you want to do? 4. Everybody take a look at number 4. How easy is this? What's my vertex? Positive 4, negative 6. Okay. What is my axis of symmetry equation? Remember, on the wall it says x equals the x value of your vertex. What is the x value of our vertex? 4. Perfect. Okay. Let's actually plot the vertex, positive 4, negative 6. That is 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Okay. That's right there. Draw your axis of symmetry right through it. Nice and easy. We need more points. Could I use the pattern 1, 1, 2, 4, 3, 9, or do I have to modify it? That depends on your A value. What's your A value? 2. So I need to modify by multiplying by 2. So my new modified pattern is no longer 1, 1. It's now 1, 2. It's no longer 2, 4. It's now 2, 8. It's no longer 3, 9, but it's 3 what? 9 times 2 is 18. So the new modified pattern from the vertex, 1 over, 2 up. Go back to the vertex. 2 over from the vertex, 8 up. Back to the vertex, 3 over, 18 up. You might not be able to use all of them. Let's see what we could use here. 1 over, 2 up. Put a dot right there. Back to the vertex. 2 over, 8 up. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Put a dot right there. And if I did go 3 over 18 up, 1, 2, 3, 18 is going to be off this graph. So I'm not going to do that last part of the pattern. But I will be able to map those points over to the other side right here and right there. How did I do that? 1 unit away, go 1 unit away. 2 units away, go 2 units away. There's your parabola. We're done. We graphed this thing. However, they do ask us for a couple of other things. We already stated the axis of symmetry equation. The domain is always x equals all real numbers. It doesn't matter if it opens up, down, if it's wide or narrow. The range is going to be y is greater than or equal to or less than or equal to. Which one? Because it's opening up, because the a value is positive, it's going to be greater than or equal to. Greater than or equal to what? Greater than or equal to the y value of your vertex, in this case, negative 6, or the k value, negative 6. What about the y-intercept? Now, you could clearly see, actually, you can't clearly see where it crosses. It's probably going to cross somewhere up here, huh? If you keep going up, somewhere way up here off this graph. So how am I going to find the y-intercept if I can't see it? You use algebra. How do you find the y-intercept? You set x equal to 0 and solve. So if I did plug in a 0 right here and then worked it out, I'd have negative 4. 0 take away 4 is negative 4. Negative 4 squared is positive 16. So what I really have is 2 times positive 16 minus 6. 2 times positive 16 is 32. 32 minus 6, that is 24. So my y-intercept is 0, 24. That means that this parabola that's pretty narrow, that's opening up, it's not going to cross the y-axis till 0, 24, way up off this graph, way up off this paper. Make sense? I hope so. We've answered everything. The vertex, axis of symmetry, modified pattern of 1, 2, 2, 8, 3, 18, domain and range, y-intercept. We answered everything about this parabola and we graphed it. So I hope this helps. Please practice doing the rest. And again, the answers are posted on Google Classroom. Let's work on this for the rest of class.